In this video, we are going to do these 4 questions from the chapter limit, and they are based on some standard limits and including trigonometric identities. We'll be using these identities to solve this question. They have been taken, 3 of them have been taken from NCERT exemplar, and this is one a textbook question, NCERT. Let's begin with the first one. The next question from NCERT exemplar, we need to evaluate this function at limit x tends to 0. So we'll be applying these standard limits to solve it. Now first I can see that if I divide the numerator as well as denominator by x, right? Dividing, you may write in the exam, dividing numerator and denominator by x over here. What we'll get here, this will get as tan 2x over x minus x divided by x is what? 1. Below 3x divided by x is what? 3 minus sine x divided by x. So actually we have multiplied and divided by x over here. Now we are going to apply the limit at all places. Let's say if I write over here, since x tends to 0, but then we can see that we need to multiply here by 2, right? Just that. Fine. So we can see over here in the first part, we can say that since limit x tends to 0 to x tends to 0, and keeping 2 outside, this is what? Tan 2x over x, not x, 2x, then minus 1. And below is what? Same thing over here. 3 is over here only, minus. If I apply the limit here also, that is limit x tending to 0, this is sine x over x. Now I just need to see the standard limits, right? So we can apply the limit at these. So we have 2 over here. Applying the standard limit, we are going to get 1 here, minus 1. This minus 1 is copied. This is 3 over here, minus, applying the limit over here, what we are getting 1. So as a result, 2, we are getting 2 minus 1, right? That's 1, and 3 minus 1, that is 2. Now this half is the correct answer. So it's B part. Check in the next question. It says we have to evaluate secant square x minus 2 over tan x minus 1, and the limit over here is what? Pi by 4. So let's begin with, first I'm going to convert the secant square as what? I can write this as 1 plus tan square, right? So this is limit x tends to pi by 4. I can write secant square x as what? 1 plus tan square x, and then minus 2 copied, and denominator will be as it is, that is tan x minus 1. So this is limit x tending to pi by 4. What is 1 minus 2 is what? Minus 1. So I can write this as tan square x minus 1, that divided by tan x minus 1. So this is limit x tends to pi by 4. Applying a square minus b square, this is going to be a minus b multiplied by a plus b, and that whole divided by tan x minus 1. All right, so here this get cancelled. It results to give you how much? This is limit x tending to pi by 4, and then tan x plus 1. So we can apply the limit. What is tan pi by 4? This is tan pi by 4, that is tan 45 degrees 1. So 1 plus 1 should give you 2. Yes, we have an option, that is D is the correct option in this case. The question here is to evaluate this function, that is tan 2x over x minus pi by 2, and we have a limit at x tending to pi by 2. So what we'll do here is to change the limit here by substituting or replacing x minus pi by 2 as y. So from here, it implies that x is what? X is pi by 2 plus y. Now further, we can also say from here that as x is tending to pi by 2, or we can say the opposite over here. We can write over here as y tends to 0 as x tends to pi over 2. Now, after changing the limit, let's say what we are getting over here, we will write now y tends to 0. This is tan This is limit tan 2 times, and what is x over here? The x is replaced by this, that is pi over 2 plus y. That whole divided by denominator, I can say denominator can be replaced with y. So we have limit y tends to 0. On opening this bracket, what we'll get? We'll get tan. This is 2 times this is what? Pi, right? And 2 times of this is 2y over. And yeah, this is y only. Now check here, we can apply this property over here, that is tan pi plus theta is tan theta. So what we can write here, limit y tends to 0, this will give you tan, yeah, that's 2y over y. One more step where we'll be multiplying by 2 and dividing by 2. So applying this, now this one, we can say that this part will give you 1. So 2 into 1 is what? 2. So we got this answer as 2. That is D is the correct option in this case. Another question from NCERT exemplar, and we have to evaluate cosec x minus cot x over x, and here the limit extends to 0 only. Same as the previous question, here also we'll be applying trigonometric identities, in fact the relation. So we can write cosec x as what? I can write cosec x as 1 over sine x, and cos is what? Cot is what? Cos x over sine x, and that whole divided by x. So next is limit x tending to 0. I can take LCM here, and that should give you 1 minus cos x over sine x, right? And there's a x as well, so I can write x over here. Now we can apply the trigonometric identity. What is 1 minus cos x is 2 sine square x over 2. 2 sine square x over 2. And this is sine x, which I can write as 2 sine x over 2 into cos x over 2. So we can see that a square get cancelled and 2 get cancelled, 2 get cancelled. Sine x over 2 get cancelled. So what we have now, let's see, check. This is limit x tending to 0. We have sine x over cos x, right? Sine x over cos x, that is tan x over, yeah, that's tan x by 2, not tan x. Tan x over 2 over x. What we can do is to multiply, divide by 2. So applying limit, this is half outside for this half, and applying the limit over here, we are going to get as what? 1. So we'll say 1 into half, that is half is the answer for this. Yeah, we have an option, that is option C is correct in this case.